Well, I'm Les Peters, N1 Sugar Vector. I'm going to talk about the NFET half-wave antenna. So, I'd been missing in action as far as NVARC field days for a while. And I remember we used to use much bigger antennas. I used to have a tri-bander that we would put on an extension ladder, 25-foot extension ladder, and raise, EO-GMO style. And I remember we used to have a tri-bander on a tower, on a trailer. But as Bruce says, this is a lot of work. And we're not getting any younger. And so I went, several years ago to field day, and John Griswold, KK1X, had this wire antenna. And I'm like, it does all these bands, and you don't need a tuner, and it actually works. I was skeptical. I'm like, no free lunch type guy. But I sat down and I operated, and I was like, hey, this is pretty good. This isn't bad. You can make contact. People can hear you with 100 watts. So after field day, I thought to myself, I should really investigate this. This is something that I should look into. And so I decided to make one. So this is the basic antenna design. It's a half wavelength on the lowest frequency. Typically you make it for 40 through 10 or 80 through 10. And the feed point impedance is 2450 ohms. So you need to match your coax, your 50 ohm coax, to 2450 ohms. So you make a 49 to 1 un. Yeah, un. And you typically would use like a counterpoise. Now you can, the antenna can be fashioned as a long wire, or what we do at field day is typically, I think it looks like an inverted L, but the total length is that. It's a good multi-band antenna. It only requires a single support. It's easy to set up, simple to build, and it's cheap. I like cheap. So here's a picture of the unun. So I decided to make one of these things, and I went out. I have enough antennas at home, but I can't put it at home. I have to go in the field and set up a mast and adjust it. So I know it's hard to see, but so on 10 meters, I basically cut the antenna because for the phone band. I wanted to cut it for the phone band. So in 10 meters, it's pretty good. It goes down to 28.3 and up to 28, 750 or something like that. Doesn't cover the whole band. There's very few levers to pull to adjust the resonant frequency on each band. It's a little bit of a balancing act. And so, let's see. And so here's 15 meters, covers all of 15 meters. 20 meters covers all of 20 meters. Again, we're under 2 to 1. 40 meters was a challenge for me. Right on the top side, it hit 2 to 1. But the problem is like if I adjust this, then that's going to move. And 80 meters, it was basically right down on the CW portion of the band. And so I guess what they tell you to do is to put a capacitor halfway between the feed point and the end to raise that. And so I started playing with different values of capacitors. And so I settled on 330 puff that moved it into the phone band. So that's my antenna. That's my NFET half wave, and I have it here if anybody wants to take a look at it. And that's basically it. So there's the capacitor. Here's the compensation coil that they tell you to put in, the unun, and the counterpoise all rolled up. Any questions?
Wes, did you wind the transformer the unun yourself?
I did, yes.
Okay, and what size core was that, and what kind of wire, and all that? What was the ratio as well?
So I mean, I'll be honest. I bought a kit for this. You can see that's HF kits.
Oh, yeah, I'm sorry, the ratio's right there.
Yeah. So there's information about buying your own material and doing. I think John did that. I didn't have a lot of time, and I thought to myself, I don't want to have to scavenge for parts and pay for shipping. I don't know what's local. And so I think I paid $35 for the kit.
So when you go to when all you guys go to these ham fests around the area, a lot of guys are selling Toroids there. Yeah. A good thing to form a bag of those of varying sizes so that you can get different power densities and things like that.
Yeah, but if you lose toroid, you never know what the mix is.
That's right. That's right.
You can buy them from somebody who's actually got them marked. Wow. And there are ways.
There are ways to
that you
determine
can figure out what they are, but it's a lot easier if you just buy somebody who knows. Somebody who knows what it is.
So if you don't get like one of these kits, like another way to go is Palomar. Palomar sells toroids, and I've had good luck with them.
About 4 years ago, I experimented with that, and one G200,
G240.
240, yeah.
240, 43.
Just one, you can go up to 300 watts. If you put two of them, you can go up to about 800. And then I tried again with three, and I found that I could go all the way to 1.5 kilowatts.
Yeah. So those who are interested too, you want 43 mix. So you want, right, 240 is the diameter of the toroid, and 43 is its mix. 43 mix is perfect for this application. Either in-fit half-wave, or Les hasn't mentioned here because he built an in-fit half-wave, means it's essentially a resonant antenna. There's the in-fit random wire. Is it really random?
No, it isn't, is it?
But it's not typical length for bands.
Yes, Leo.
It's fun to do. It's easy to do.
What's it rated for, power-wise?
So this one, it's a single toroid. They say it's rated for 250 watts. I would just use it barefoot and be happy.
Yeah.
What happens is permeability is lost when it gets hot.
Right.
Yeah.
And you lose energy.
One toroid, you go 500 watts, you see it smoking. And once it starts smoking, it never recovers.
If you don't have your hand on it, you'll know your SWR will start to get out of whack pretty fast. Cool it off.
And if anybody's interested, here's some links. There's a bunch of YouTube videos here and other information. Just send me a note. I'll be happy to send the slides over. There's a lot of good information, especially about the cap for 80 meters and there's one of these I think is about the triple core to get more power. So.
You lose 10 meters because of the classes.
Yep, losing 10 meters. Okay. Anything else?
So the NFET wave has become hugely popular recently. The main reason is that if you live in like an antenna restricted development, you can run a thin wire out, which hopefully won't be seen and is low profile, and you can feed the coax in the box from an end that's hopefully like concealed at your home kind of thing. And so
That's mine.
this combined with activities like parks on the air, okay, have made it really a very, very, very popular antenna. And I know every time I've played with one, it's been mostly on field day, but I think they've performed extremely well.
I think it's a great field antenna. I mean, it's cheap, it's easy to set up. Even I could make one. Yes, Leo.
What about mounting as far as the height?
So,
One end to the other, is it a slope? Or?
so the question is mounting. So you can mount it as a long wire. Okay, or you can mount it as an inverted L. We typically do that for field day. So you use one mast, and the antenna goes up one side and over.
Or an inverted V. Yeah. You got mast in the middle, up, back down.
Yep.
Yeah, not to confuse things, but this is actually a dipole. Most people, when they think of dipole, they think of two poles, two wires. Dipole as an electrical engineering concept is essentially a low point, a high point, and then a low
Right.
point, and that occurs on that antenna.
True.
So you can actually mount this like you would mount a two-wire conventional dipole as seems to. And as Bruce said, it works quite well.
How much of a problem is it if it's like too close to a house or a lot of trees and need the blockage? Just go right through that?
I don't think there's any issues. I mean, as long as it's not near anything that's like really, really close, then it's metallic. Like, you know, if it was really close to a tower, I don't know. You know, I have issues, but
It's got all the same restrictions as you would.
any other antenna,
Regular doubles out,
right? Yes.
One of the antennas we use in Granite State is a chameleon M.2. It can be set up as an end fed, as a dipole, as an inverted L. We've done all of them. It's plug and play. We set it up 1 to 2 feet off the ground, the coil, and as high as we can get it, the other. It works.
Great, great. Okay. Thank you.
Thanks, Liz.